So bell work number 7 is a review of the rules of exponents, and we're not going to do all of them. I'm going to do some of the more common ones that we'll see. And on problem number 1, we know that we can multiply 5 times 2, and that's going to give us 10. So that rules out these two options. And let's see, what do we do with the exponents when the bases are the same and we're multiplying? Well, notice that here and here the bases are the same. They're both x. And that means since we're multiplying, we add the exponents. So that's going to give me x to the power of 3 plus 2, which is 5. So the final answer would be 10x to the power of 5. Number 2. Number 2, we have the cube root of 512. And the cube root of 512 can be found by entering this into the calculator. 512 raised to the power of 1/3. Now, why is it that way? Because this is 512 to the power of 1, and this index here is a 3, so that's going to be 1/3. So here's the rule. If you have the nth root of a to the power of m, then you can rewrite it as a to the power of m over n. Okay, the answer is 8, also because 8 times 8 times 8 is equal to 512. That means the cube root of 512 is equal to 8. Number 3. On number 3, luckily the bases are the same and we're multiplying. The bases are both 4, and since we're multiplying, we will add the exponents together, and 3 plus 5 is 8. So the answer is 4 to the power of 8. Question number 4. According to exponent rules, when we multiply terms with the same base, we add the exponents. We've already done that a couple of times during this presentation. So when the bases are the same and we're multiplying, we add those exponents together. Question 5, according to exponent rules, when we divide the expressions, we subtract the exponents. If we're dividing, we subtract. Question number 6, remember, any number raised to the power of 0 is equal to 1. That's a rule. Any number, whether it's positive or negative, a fraction or a decimal, doesn't matter. If it's raised to the power of 0, and that's what we're doing here, the answer has to be 1. Number 7. On number 7, we have a fraction here, and we could break this up into multiple parts. And let's see. Let's divide 3 into negative 12. That's going to give me negative 4. And notice I have x to the power of 4 divided by x to the power of 1. And we said that if the bases are the same and we're dividing, we subtract. So 4 on the top minus 1 on the bottom means that I would have a power of 3. And then y is going to be raised to the power of 1 because 3 minus 2 is 1. And it appears to me that that answer is not on here. That answer is not on here. So it looks to me like they left the 3 off for this exponent here. So if you missed it because you got this, that's actually a good thing in this case because there is an error on here. Okay, question number 8. Question 8. Okay, on this one, we have to go back and think about this. We have a power to a power rule that's going on here. So let's take care of power to a power. Well, if you have power to a power, you multiply. So that's going to be 4 times 2. That means I have a to the power of 8. And then I have b to the power of 2 times 2. So that's b to the power of 4. So I have now rewritten that. And now I'm going to multiply that times this one. Well, a to the power of 8 times a to the power of 1. We have to add those exponents on the a's, so that's going to be a to the power of 9. And then b to the power of 4 times b to the power of 2 is b to the power of 6.